Let's learn about the force. Force equals many things. Let's start with the first basic one. That would be F equals ma. This is the force equation everybody uses. It's just mass and acceleration over here. So this is all about acceleration. But what if they just give you velocity? Then we know that force is equal to the derivative of velocity over time. Certainly true. This is if you know velocity. And really the trick with these force equations is that you're probably just going to be given a certain variable, you know something, and you need to know which force equation to use. So those are two of them. Let's go to the next one. Perhaps you're given angular acceleration. That would be sort of more like this alpha. This is angular acceleration, equation 3. You know, maybe they're given centripetal acceleration or something, so F equals mv squared over r. Here's another velocity equation, but this would be tangential velocity. Tangential velocity. This would be more centripetal force here. So that's the fourth equation. Let's see, there's a couple other ones that you might know here. So what about derivative of work over distance? Equals F. This is number 5 here. And then that's also maybe potential energy over dx. So this right here is work. And, you know, like I said, depending on what information you're given, you need to know one of these equations. We're just going to keep going. There's a couple more. Maybe you know momentum. So the derivative of momentum over time is also equal to force. This is momentum. You don't really have to memorize these equations. You just want to write these all down in your little cheat sheet so that you know them, so that you have them available to you. Here's another one, number 7. This would be F equals mu n. And this could either be static or kinetic friction. So perhaps you're given the coefficient of friction, and that's the one that you need to use, that particular formula. Maybe you're just given the momentum. Maybe you're given potential energy or work, and you can figure out what force is based off of that. Maybe you're given velocity, either tangential or the regular velocity. Maybe you're given this particular alpha, or just the regular acceleration. These are some different ways you can calculate force. I'm assuming you're given mass. Everybody's given mass. So let's keep going. What about number 8 over here? Here's a couple different ones. Maybe force equals AP. This is pressure. This would be area right here. And, you know, that's pressure. Might be density or something. I'm not exactly sure. But some of these equations, I can't remember entirely how to use them. Some of them, you know, like I said, they're just to have handy just in case you need to refer back to them later. Then we have the damping force. This is just BV. Actually, we should take a look more at DVG, this one over here. DVG, this would be density. Let's say you're given density. And let's say, you know, so this is the equation number 9. Sometimes density already includes, may include G already. It may already include G, so you may not even have to calculate that. Like I said, this is You want to make sure that all of your calculations end up being in Newton at the end of everything. So that way you are sure that you've got the correct equation, because, you know, maybe sometimes you might not have something quite right. You just have to make sure that it's the Newton at the end of everything. This would be kg meters per second squared. Something like that. And then there's just a couple more. So I was writing this one here. The damping force is BV. This is some sort of a constant, the damping constant. You know, like I said, these are just some equations that you might have to refer back to later. The F external here, cosine WDT. This is the external damping force. Now, I've never even used this equation, but let's just say you're given this, and I don't know, maybe this initial force or something. And with that, hey, you can figure out what the external force is. You know, maybe you're given B. Maybe, I don't know, I don't even remember what P is. Maybe you're given P. But you just want to be aware that these equations exist, so that way you can refer back to them just in case you have to solve something with these equations. This is equation sort of number 10 over here. And we also have the equation for simple harmonic motion. That would be mw squared x. This would be like the omega here. This is the amplitude. So angular acceleration, or amplitude, right there. And this is for simple harmonic motion. So that's another force. And I think there's one more final force you might want to take a look at. It's the spring force, F equals kx. Put that just a little bit lower here. Number 12. F equals kx, because it also equals m, and then the second derivative of distance over time here. This is again the spring force. This is a good one. Again, remember, these are just to have handy in case you're given k. And you need to remember what the equation is. Well, it's just kx. Or maybe you're given the second derivative of x, or, you know, hey, there you go. From this equation, we get two little equations over here, which are kx equals ma. It's a nice, important equation, 12.1. And then there's also k over mx equals second derivative of x over time here. And this is again equation number 12.2. So all these are equations that you might want to just have written down. Maybe the ones that you do understand, maybe all of them, maybe the ones even that you don't understand, because it doesn't hurt to have extra equations written down, just in case you need to have them later to refer back to them, so you're not completely lost. So these are the different types of force equations. Now it's more important that you able to be able to create force diagrams for all the problems that you have to solve. So that's going to sort of be the topic for the next video, and let's go ahead and just take a look at that. Make sure to like and subscribe if you enjoyed all these videos.